Hey guys, welcome back to my channel, Hayat tutorial. So finally today we are going to read the second unit, that is relative density and its measurement by Archimedes Principal. In the previous unit we read about upthrust, that fluid exerts pressure in all the direction, and the pressure exerted by the fluid on the body, that is called upthrust. And we read about Archimedes principle, that when a body that is completely immersed in a liquid, it experiences an upthrust. That is a force by the liquid. So let me tell you, in this unit, there are mainly, we are going to read the formulas, and at the end of this video, we are going to solve few numericals. So let's start without wasting any time. So first thing is the formula of density.
Density is the relationship between mass and volume, or you could say it is the formula is mass of the substance upon the volume of the substance. You would have read about density in your previous classes. What is mass? Mass is the amount of matter inside in an object. And volume, that is the amount of space it occupies. For example, if we take any kind of liquid and we put that liquid in a glass of water, then the water that will take the shape of a glass. So that the amount of a space that the liquid occupies, that is the volume of the liquid. And mass, that is the amount of matter inside the liquid. Okay, so this is your definition of density, and the formula is mass of the substance upon the volume of the substance. Okay, and one more important thing, that is it is a scalar quantity. It is a scalar quantity, and the unit of density, that is how to derive the density, a unit of density, that is the SI unit of mass is kg and the SI unit of volume is meter cube. So concluding this, the unit of density, that is kg meter minus 3, because वॉल्यूम जो फॉर्मूला है उसमें वॉल्यूम नीचे आता है, तो जब वॉल्यूम ऊपर आएगा तो -3 हो जाएगा. So basically the SI unit of density, that is kg meter minus 3, and the CGS unit, that would be gram centimeter minus 3.
So I told you that it is a scalar quantity. The SI unit is kg meter minus 3 and the CGS unit is gram centimeter minus 3. Now the relationship, that is very important. So 1 kg meter minus 3, that is equal to 1000 gram centimeter minus 3. 1 kg is equal to 1000 gram, 3 zeros. So here 10 की power minus 3 gram centimeter minus 3. Okay, and the opposite, that will be this 1000 kilogram meter minus 3. Next is, what is the effect of temperature on density? The density of any substances that decreases with the increase in temperature, and when the density when the temperature decreases, then the density will increase. So density is indirectly proportional to temperature. Now it's important for you to know this, the density of water, that is maximum at 4 degrees Celsius. The temperature here is decreased, so the density will increase. That is equal to 1 gram centimeter minus 3, or you could say simply 1000 kilogram meter minus 3. Okay, the temperature that decreases here, that is 4 degrees Celsius, so the density will increase. Next is our relative density. Now relative density is very important, because through this we are going to study, we are going to solve the numericals afterwards. So basically, relative density of any substances, that is the ratio of density of the substance to the density of water at 4 degrees Celsius. We have read that the density of water at 4 degrees Celsius, that is the density of water that is maximum at 4 degrees Celsius. So with this thing, we can calculate the relative density of any substances, and the formula is density of substance, density of water at 4 degrees Celsius. So you can define relative density as the ratio of mass of certain volume of substances to mass of an equal volume of water at 4 degrees Celsius. Or simply you can write the ratio of the density of substances to the density of water at 4 degrees Celsius. If you know the formula, then you can easily derive the definition of that particular term or word. Now it is important for you to know this, that it has no unit. Relative density does not have any unit, and again it is a scalar quantity. Now how are density and relative density related? Now we could know this, that it is very simple, that for calculating relative density we need to know the density of that particular substance. So the relationship is that the relative density, that is the numerical value of the density. In SI unit, the density of water 4 degrees Celsius, that is 1000 meter minus 3. We read here, this is the CGS unit, this is the SI unit. Sorry, this is the CGS unit, this is the SI unit. So through this we can conclude the relative density of any substances. Here this formula. For example, if a density of copper, that is 8.9 grams centimeter minus 3, then its relative density, that will be 8.9. Next is the differences between density and relative density. Density, we read that is, you can write, it's very simple. If you know the formula of both these terms, then you can easily derive the definition. We read the formula of density, that is mass upon volume. So you can write density of a substance, that is a ratio between the mass of these substances to the volume of the substance. And for the relative density, the formula was density of the substance to the density of water at 4 degrees Celsius. So you can easily derive the relative density of a substance, that is the ratio of density of that substance to the density of water at 4 degrees Celsius. So it is important for you to know the formula of these two terms. And we read about that the unit, the SI unit is here gram, kilogram, meter minus 3, and relative density has no unit. Note, it is the difference between density and relative density, so you can't write it is a scalar quantity, it is a scalar quantity. So there would be no difference. For understanding this, we need to see an experiment.
It's an experiment that is first the procedure is that take a piece of ball or a stone and tie it with a thread from a hook of a physical balance and find its weight. This will be the weight of the solid in air, means W1GF. Now that tied stone, immerse that stone in the given solid, and then you can weight that and find the weight of the solid in water. This will be the weight of solid in water, that is W2GF. So now for calculating the relative density, the formula is the weight of the solid in air, W1, upon the loss in weight of solid in water, that is W1 minus W2. So this is how you can calculate the relative density of a solid when it is immersed in water. Okay, so through this we can conclude that the mass of water of volume to that of the body, that is obtained by finding the mass of the water displaced by the body when it is completely immersed in water, because body when immersed in water, that displaces a water equal to its own volume. We read that in the previous lecture, in the previous video. So To find the relative density of a solid body using the Archimedes principle, we need to weigh the body first in air and then in the water. And if the weight of the body in air is V1 and in water that is W2, then the formula that will come derive RD is equal to W1 upon W1 minus W2. W1 is in the weight of the body in air and W2 is the weight of the body in water when it is immersed. So this is a formula that you will use. This is how we can determine the relative density of a body substance by the Archimedes principle. And the experiment that I told was the questions can come related to the experiment. Second thing is the RD of solid denser than water and is soluble in water.
This, the RD of a solid denser than water and soluble in it. If a solid that is soluble in water, so we will take the liquid. So in this, for calculating the RD, the relative density of the solid, which is denser than the water, so the formula that we will use is the weight of the solid in air, loss in weight of the solid in liquid. It is same as that of the solid denser than water and soluble in it. This is insoluble and this is soluble. So for the soluble, we will take the liquid of known relative density in which the solid insoluble, that is the RD of the liquid in which the body that is soluble. Next is a determination of relative density of liquid by Archimedes principle. Now for this we have taken, it's the same as that of we did this experiment, but here we have taken two types of liquid. One, it is just a liquid. It could be petroleum, kerosene or mercury or any kind of liquid. And second thing is in water. So we will perform the same experiment but in two liquids. So the procedure is, take a stone, tie it to the hook of the physical balance, weight the stone in the air, that will be W1, then weight the stone in the liquid, that will be W2, and then weight the stone in water, that will be W3. So the relative density of the liquid, that will be W1 minus W2 and W1 minus W3. W1, that is the weight of this substance in air, W2, that is the weight of the substance in liquid, and W3 is the weight of the substance in water. So this is the equation, and through this our second unit gets completed. Now we are going to solve few numericals. So now we are going to solve numericals, at least three numericals. One is 16, 3 and 13. Okay, so let's start solving. So the things that are given is the density of iron. The density of iron is 7.8 into 10 to the power 3 kg ms and minus 3. Now for calculating the RD, the formula is density of substance upon the density of water. Okay, you will use the formula. Density of substance is 7.8 into 10 to the power minus 3 kg meter square, and the density of water is 10 to the power minus 3 kg. So it will cut and the formula answer will come 7.8 answer. Okay. Note RD has no unit, so it will be just like this. So next is a solid weight 1.5 kgf in air and 0.9 kgf in the liquid, and the density is 1.2 into 10 to the power 3 kg meter minus 3. We have to calculate the RD of a solid. So if you remember this, that the RD of a solid is denser than water and soluble in it. So for calculating that question, we are going to use this formula: the RD of liquid, the weight of solid in air, and the loss in weight of solid in liquid. So given things are, first in air, the V1 is 1.5 kgf, V2 in water, that is 0.9 kgf, and the density is 1.2 into 10 to the power 3 kg meter minus 3. For formula that we are going to do uses RD is equal to V1 upon V1 minus V2 in brackets into the RD of the liquid. So formula is V1 is 1.5 minus 0.9, solve it, then 2 into 10 to the minus 3 is equal to 1.5 by 0.6 आ जाएगा into 1.2 into 10 की पावर माइनस 3 आ जाएगा because RD है, तो the RD that will be just 1.2, so it will be 0.320. This is the answer. This is how we will solve. Next question is, a piece of stone of mass 15.1 is first immersed in liquid and it weighs 10.9 gm. Then on immersing the piece of stone in water, it weighs 9.7 gf. So calculate the weight of the piece of stone in air, the volume of piece of stone, the relative density of stone, and the relative density of liquid. First of all, let's write the given things. So the given things are, first of all, the mass of stone, that is 15.1 kg. Then the weight is 10.9 gf. It is in liquid. Next is then in water. Weight in water, that is 9.7 gf. So first of all, we need to calculate the weight in air. So for calculating the weight in air, that will be, first of all, read the question carefully. The mass, piece of stone of mass 15.1 g. At first, the mass at normally in air, that the mass is 15.1 g. So eventually it will be gf. 15.1 gf, that is the weight of the piece of stone in air. So here the first is, that's why you need to read the question carefully. Second says the volume of piece of stone. So this is the experiment that we did in Archimedes Principal. Imagine that you have a glass of water and you place a stone in the water, and then you will see that the water level that will come up. Why is that? Because of the volume of the stone. So similarly, the normal volume of water minus the volume of stone, मतलब यहाँ पे जो normal जो mass है stone का, that will be subtracted from the weight of the stone in water. So the V1 minus V3. So the formula, that is it is 15.1 minus V3 is 9.7. Answer will come 5.4 centimeter cube because volume है. Third is the relative density of a stone. V1 is given, V2 is given, V3 is given. So you know how to calculate the relative density of a stone, that is RD is equal to V1 minus V2 upon V1 minus V3. Next is the relative density of a liquid. Next is the relative density of a stone. For calculating this, you will use this formula. Rd is equal to V1 minus upon V1 minus V2. Next is for the relative density of the liquid. We will use this formula. Rd of liquid V1 minus V2 upon V1 minus V3. That's it. And that's what I want you to answer in the comment section with the following steps. Because it's very easy. You just need to place the values and then you will get the answer. So this was a chapter. Next chapter is the floatation. That is the last unit of this chapter, Upthrust in fluids. And this chapter is very important. Reasons will come from this chapter, maybe. So if you like the video, give the video a big fat thumbs up, and don't forget to share it with your friends. Comment the solutions of this and subscribe our channel for more updates.